Hi everyone, this is Mrs. GA, and today we are going to talk about translations. So in example 1, we are going to be translating figure A, B, C, D using this rule. So we have done translations in this method before, so remember, the way this works is you list out your original coordinates. So A would be 2, -2, B would be 6, -2, C would be 6, -4, and D would be 2, -4. And we essentially go in and subtract 3 from all of our x values. So A prime, B prime, C prime, D prime. So I subtract 3 from all of my x values, so -1, 3, 3, -1. And then I'm going to add 7 to all of my y values. So we have 5, 5, then 3 and 3. And then I'm going to take a moment and plot these new coordinates, the coordinates of our figure, on the graph. Okay, so here's my new figures. So you can do this, or you can interpret the rules of this translation. So we know that this rule means to move to the left 3. This rule means to move up 7. So I could do that to each point, left 3, up 7, and that would give me the same result. So today we're going to talk about translating figures using vectors. So first, let's talk about what a vector is. A vector is a quantity that has both direction and magnitude, which is essentially a length. So it's going to be pointing in a direction, and it will have a length. The initial point of a vector is the starting point, and the terminal point is what we call the ending point of a vector, and it will have an arrow on it. So you can either draw a vector that they look like this, so here's our initial point and here's our terminal point, or you can write it in component form. So the way you write the component form of vectors, you use kind of a pointy parenthesis and then A, comma, B. So A is always going to represent horizontal movement, and B is going to represent vertical movement. So if you see a vector, it's essentially just telling you how much to move left or right, and then how much to move up or down. So in example 2, we're going to look at 3 different sub-examples. We're going to write the component form of the vector we see, and then we're going to draw the image after the translation along the vector. So again, this is going to be the initial point, and we call this the terminal point. So essentially, I'm just going to count my horizontal movement. So I can see that I moved to the left 3, and then I moved up 1, 2, 3, 4, 5, 6, 7. So that means the component form of my vector is -3 because I went to the left 3, and then +7 because I went up 7. So pretty much what I'm going to do is I'm going to take all of my points and I'm going to move them left 3, up 7, like I just did in the previous example. And you get that same image. So you can see that if I connect A to A prime, it's that same, this vector, except I moved it so it started at point A, and it shows me where to end. So you could also do that for each of your points. You can draw that same vector from each corner of your figure, and that will tell you where your new figure lies. So let's look at this next example. So I can see my vector is down at the bottom, so this is my initial point and this is my terminal point. So I can see that I went to the left 2 and then up 2. So that means the component form is -2, 2. That means I go to each of my coordinates of this figure and I go left 2, up 2. So D prime is going to be right here. E prime is going to be here, and F prime is going to be right here. And then I connect my dots, and I'm done. And again, you could always start with the vector on each of your points, and they will tell you where your new points will fall. Okay, let's look at this last one. So when I have a vector that isn't hitting exact points and I can't tell the exact coordinates of the initial or the terminal, what I'm going to do is I'm going to draw this vector starting from each of my points, and I'm going to actually use the vector to transform it. So I can see that my vector moves to the right 3, and then I'm going to kind of estimate how much it moves up. So from this first, how about from C, I'm going to move to the right 3, and then it kind of goes up about this much. And I'm going to do the same from B, so it moves to the right 3 and it goes up about this much. So you try to kind of maintain the same angle. And for the last one, I can go right 3 and it moves up about this much. So imagine you're just replicating this exact vector. You pick it up off your page and put it here, here, and here. And these will be your new coordinates. So this will be C prime, this will be A prime, and this will be B prime. And here is your transformed image. And there you have it. And again, this one we can't name the exact component form because we would be estimating. So we can just use the vector to transform. Okay, so now we're going to review the rules for translations on the coordinate plane. So we know that if we want to move our figure to the right or left, we're going to add or subtract from our x value. And if we want to move our figure up or down, we're going to add or subtract from our y value. So we can do the same thing with vectors. Just remember the first part of your vector is telling you left or right, and the second part is telling you up or down. So let's give this first one a try. So here they tell us the coordinates of our pre-image. So let's graph that really quick. Okay, so here's our pre-image, and they would like us to transform it using this vector. So this vector is essentially telling us that they would like our graph to go left 3 and up 1. Which means I'm going to add 3 to my x values subtract 3 to my x values and add 1 to my y values. So let's list our pre-image coordinates. And if I subtract 3, I get -6. Add 1, I get -1. So that's A prime. For B prime, subtract 3 and then add 1. And for C prime, again, subtract 3. Add 1. And then we're going to go and graph those again. And there you have it. So another way you can do this is you can actually just start at each point and go to each point and say, I'm going to move it left 3, up 1. Or a third option is you can actually draw in your vector for -3, 1 from each original point. So you can go like this. So you can see that they all move left 3, up 1. Okay, the last thing we're going to do is we're going to look at an image and its pre-image, and we're going to see if we can find the component form of the vector. So what I'm going to do is I'm going to draw my vectors connecting my image to my pre-image to my image. So from A to A prime, so that'd be the vector. I can do the same for all of my points. And there you have it. So that's the vector. So the component form, remember, is just the horizontal movement and the vertical movement from initial to terminal. So I can see that I move 1, 2, 3, 4, 5 to the left, giving me -5. And then I moved 1, 2, 3, up 3. So my component form is -5, 3. And remember, we always write this with little pointy parentheses. Okay, that is all for today's lesson. Thank you so much for watching.